Hello everyone. Today we are going to see about organic chemistry. The word chemistry might be little boring to you, but the word organic chemistry might be of large interest to you. Why? The word organic means something related to the living beings. Like we eat fruits, vegetables, we consume them organic, right? We eat flesh, we eat fish, we eat eggs, organic in nature, right? Some you may say beans, organic in nature. So organic chemistry, the word organic, it means everything related to the living things. Its knowledge is important, right? Its study is important. Knowing more and more about those things will always help you out. So compared to the other chemistry that you have gone through, that is the inorganic chemistry, organic chemistry might be of large interest to you. It is because inorganic chemistry has got a little scope, but organic chemistry, it has a very vast amount of scope, right? Organic chemistry is applicable in everything that is around you, just starting from the food we eat, the clothes we wear, right? The things we use, the plastic, right? The medicines we consume, right? Anything, any material you may say, everything involves the organic chemistry. So organic chemistry, it is a chemistry related to the living things, and apart from the living things, right, there are also many more compounds which are not the part of living things but also are studied under the topic organic chemistry. So what exactly is a organic chemistry? Organic chemistry is the study about the compounds that are related to the living things. What are those compounds? Let's talk about we humans ourselves, right? So we have a fat in our body. So you might have ever thought that how do this fat look like? How this fat gets stored up? What is its structure? Right, we work, we put on large amount of exercise to melt down the fat, we to make ourselves fit and fine. So those fat molecules are organic compounds. If you know the structure, if you know their properties, right, you can decide what to eat, what not to, right? You may think of proteins that we take in, right? The wheat that we take in. You drink tea, right? It has got caffeine in it, right? Not caffeine, or maybe some other intoxicating substance in it. Its structure, how does it exactly affects? Smoking we do, right? The smoking, once again, it contains some compounds, right? How does it affects our body? So organic compounds is related to all the molecules, all the compounds that are related to our body directly or indirectly. So the structures, how they are made, how they are digested, how they are placed, what are their effects, many such things are involved into the topic organic chemistry. So it has got a vast scope. Out of that vast scope, these lectures will help you to understand some basic concepts, some terminologies that are related or that are included into it. So beginning the organic chemistry, how the organic chemistry evolved. So very earlier on the, let's say in the 18th century, in the 16th century, it was believed, right? A scientist called as Berzelius. Berzelius, he said that organic compounds cannot be prepared in the laboratory. Organic compounds, no organic compounds, like you may say fat, you may say proteins, you may say vitamins, you may say glucose, medicines, nothing as such can be produced in the laboratory. That was the sentence given by Berzelius. He said that vital force is missing. Vital force means the force, right, which produces or which gives the life. So organic compounds, since they are related to the living beings, right, they can be produced only by the things which are live in nature, which are living in nature. So that was the concept held by the Berzelius. We call it as a vital force theory, that no organic compound can be made in the laboratory. But as the time went on, right, there were researches that why can't we make the organic compounds. So the first breakthrough was given by the Wohler. Wohler, he prepared urea in the laboratory. Urea is an organic compound, right, related to our body. When we urinate, urea is the main component of the urine. It's a toxic substance removed from our body. So Wohler prepared urea. He prepared urea in the laboratory, and then finally he gave a death blow to the vital force theory. He proved wrong, that no, vital force theory is totally wrong. Organic compounds can be made in the laboratory, and the urea was the first organic compound made by Wohler in the laboratory. Formula of the urea is NH2CONH2. If you go structure wise, this is the structure of the urea, right? It has a carbon doubly bonded to the oxygen, and on the side it has a amine NH2, and on another side also it has a amine NH2. So this is the structure of the urea. Three-dimensionally urea looks something like this. This is the central carbon, and then you have a doubly bonded oxygen. Then here you have a nitrogen. Nitrogen is trivalent. So one valency hydrogen, second valency hydrogen, and third valency bonded with the carbon. Same on the other side, right? Here you have a nitrogen bonded to the hydrogen and hydrogen. So organic compound was made in the laboratory. Now in this session, we will analyze how this can be written, how this can be drawn, right? What are the aspects, features, basic alphabets regarding forming such structures. How did Waller got to know that this is how the urea is? So all such things we will analyze in this session. So urea, by preparing urea, Waller said that yes, all the compounds related to the organic things, living beings, can be prepared in the laboratory. Discussing about the branches of chemistry, apart from the organic chemistry that we are going to discuss now, there are also other branches in inorganic chemistry. You might have gone through many things about the inorganic chemistry, right? You might have studied about the salt, the NaCl. You might have studied about the sulfuric acid, H2SO4. So all such things which can be obtained naturally or which are obtained naturally falls into this topic in organic chemistry. Directly or indirectly, they are part of our diet, they are part of our body, right? So in organic chemistry, such compounds, NaCl, H2SO4, copper sulfate you may take, right? Water you may take. All study of all such compounds fall into the organic chemistry. Biochemistry, it is a special branch of the organic chemistry. Biochemistry deals with the compounds to the living beings and specifically to the animals, right? Organic chemistry, it's little vast, and within that vast topic, biochemistry is a smaller topic. Then we have a physical chemistry, all related to the calculations. You might have done calculations of the moles, how many moles of the react with how many elements or how many compounds they react to form how many moles, how much grams of the gas is given out, right? And all such calculations, quantitative analysis is present in the physical chemistry. So basically inorganic, physical, organic, and analytical chemistry. And in analytical chemistry is all about doing things in the laboratory. You mix up two things, you find some color, you make some conclusions, right? So analytical chemistry, titration is one method through which you identify the substance, acids and base. And then a flame test, which help us to identify the ions like sodium, calcium, magnesium, because those ions on burning give a very beautiful color. So analytical chemistry talks all about laboratory. Physical chemistry is all about calculations. Biochemistry is all about living beings. Inorganic chemistry is all about the compounds that we found in nature, which are related to us directly or indirectly. And organic chemistry is a very big branch which involves the compounds of carbon. Organic chemistry, its knowledge, its discussion revolves all around the carbon. So organic chemistry is about the carbon. So organic chemistry, its definitions, trying to understand what exactly the organic chemistry is. There are multiple definitions given in multiple textbooks. You can make your own. Some of the definitions I have listed out over here. So what organic chemistry is? I said that organic chemistry is related to the compounds which are found in living beings, right? Fat, you may say, nucleic acid found in the DNA. In fact, DNA itself is a organic molecule found in the living beings, right? So what is the organic chemistry? Organic chemistry, it's a study of structure, properties, composition, reactions, preparations of carbon containing compounds. Please make a note. Organic chemistry, one synonym right, is carbon containing compound. Carbon is a central atom. Organic chemistry, it all exists because of carbon. So apart from the carbon, another important element which you will find in organic chemistry is hydrogen. So carbon is the first important, hydrogen is the second important, and apart from the hydrogen, right, organic compounds also contain nitrogen, oxygen, halogens, phosphorus, silicon, sulfur, and many other elements, but in very less category. So majority it is carbon, then secondary it's hydrogen, and then nitrogen, oxygen, halogen may not be present, but carbon and hydrogen are always there for sure. Another definition of the organic chemistry says that it is a carbon containing compound including their structure, properties, composition, reactions, preparations. It's a major branch of the chemistry that focus on how carbon forms complex molecules like fats, vitamins, proteins, right, lactic acid, any such things, you may say glucose, starch, sugar, alcohol, all such things, starting from the very simple molecule like methane, going on to the very complex molecules like fats with different structures and functional groups. We'll understand the functional group is also a very important word in the organic chemistry. As the discussion goes on, we'll understand what exactly the functional group is. The third definition, chemistry help us understand how chemical process occur in living organisms. Any chemical process, you may say, I said that we eat food, fat gets stored into the body, right? Sometimes, let's say when you are fasting, the same fat gets burned up. So how exactly the fat look like? What are the atoms, elements, molecules involved in the fat? How it is placed, where it is placed, how it is extracted, how it is burned, how energy is produced, all such things includes in the organic chemistry. For example, by studying the structure and molecular transformation of nucleic acid, enzymes, proteins, we can harness their full potential, right? So if you know nucleic acids, enzymes, or any such compounds, right, you can exactly identify, let's say a human body, right? We consume food, we try to eat healthy, but many a times a situation arises that our body lacks certain vitamins, certain acids, right, certain compounds our body lacks. So how do we get them? So we take in medicines. So medicines are made from the knowledge of organic chemistry, right? Doctors analyze that, okay, the person so and so is suffering from certain problems, so such acid or some enzymes or such vitamins, some iron tablets, some calcium tablets must be given, right? So how those are made? Those are made exactly by knowing the structure and the molecular structures and all such things. Again, they are part of the organic chemistry. Organic chemistry got its name from the fact that in 19th century most known carbon compounds were thought to come from living organisms. The vital force theory given by Berzelius, right? Earlier, all such organic compounds were extracted from the plants, from the animals. So from there, the name came in organic chemistry. However, then the organic compounds were also nowadays are prepared in the laboratory. Organic chemistry is different from inorganic chemistry, which is the study of compounds that don't contain carbon. Actually, this statement is contradictory. It's not exactly that don't contain carbon. They contain carbon, but they are not part of the living processes, or they are very little or lesser part of the living chemistry. So inorganic chemistry, it talks about the compounds, right, in which carbon is not the essential element. You may say like CO2, you may say carbonic acid, right, or you may say sodium bicarbonate. So all such compounds also contains carbon, but carbon is not the central atom, or it's not the atom which gives the property to these compounds. Please mind it, these are the inorganic compounds. Their properties are collectively because of all the elements that are within. But when we say organic compound, right, the carbon is the main constituent. Without carbon, no organic compound exists. I said the carbon is the primary, hydrogen is the secondary, and then other elements may not be present. Another definition, organic compound, it's a large class of chemical compounds in which one or more atoms of carbon, just make a note, one or more atoms of carbon covalently bonded. So in organic compound there is a carbon, and carbon is covalently bonded to the atoms of other elements. What other elements? Many other elements. Many other elements compared to all the elements, right? Compared to all the elements, like let's say if it's a sodium, sodium combines with chlorine, sodium combines with hydrogen, sodium combines with oxygen, but sodium cannot combine with all the elements. So when you compare, carbon is the element which can combine with maximum number of elements. The few carbon containing compounds are not classified as a organic, like carbides, carbonates and cyanides. I said that such compounds has carbon, but the properties are not because of carbon, it is because of collectively all the elements. Like if you say cyanides, hydrogen cyanide, if you take HCN, so property of the HCN is not because of carbon, it is collectively because of all three. When we say organic compound, the property is the main feature, the central discussion part is the carbon. Organic compounds, their characteristics, their properties. Now what is a specialty about the organic compounds, right? So first specialty or first important part of the organic compound is a structure. Organic compounds may have a simple structure, right? Like you may say methane, the molecular formula of methane is CH4, a very simplest organic compound known. And then you may take other one, a complex or little complex organic compound, let's say ethanol, C2H5OH. So slightly complex as compared to this. So organic compounds, they may have simple structure, they may have a complex structure. If I draw that structure, it would be somewhat like this. Carbon on four sided bonded to the hydrogen, and here carbon carbon OH and bonded to the hydrogen atoms. You can count it up, right? So this is the ethanol and this is the methane. So structure of the organic compounds may be as simple as this, may be as complex as this, and much complex than this. Have variable molecular weight, smaller molecular weight, larger molecular weight. Solubility, organic compounds, please make a note, organic compounds are soluble only in organic solvents. Organic compounds are soluble in only organic solvents. What are the organic solvents? Ether is a organic solvent, carbon tetrachloride is a organic solvent, toluene, petrol is a organic solvent, alcohol is a organic solvent, right? So organic compounds are soluble only in organic solvents. They are not soluble in water. For example, let's say you take a edible oil, you put it into the water, keep on shaking it, it won't get mixed up. So organic compounds are insoluble in the water. Flammability, some of the organic compounds are flammable, some of them are inflammable. Like you may take plastic, once you burn, it keeps on burning, flammable. But if you take Teflon coating, right, you have a non-stick cookware, it has a Teflon coating on it. So that Teflon, it's not an organic compound, but you can say it's a part of discussion of the organic chemistry. So flammability, organic compounds, they are combustible. Organic compounds, some of them are combustible, some of them are not. I said plastic, some plastics are combustible, some plastics are not. The Teflon coating on the cookware, right, don't allow food to burn. Heat resistive, they do not burn. Melting point, boiling point, they depend upon again the structure. Methane, the simple structure, right, it exists in the gaseous form. Ethanol, right, little complex structure, it exists in the form of liquid. So melting point, boiling point may depend upon the structures. But compared to the inorganic compounds, organic compounds have a variable melting and boiling points. Polarity, organic compounds may be polar, may not be polar. Polar means having the charge, right? If I say hydrogen chloride, hydrogen has a slight positive charge, chlorine has a slight negative charge, polar in nature. But if I say methane, right, no such charge exists. So polar means having charge on the atom. No charge on any of the atom means non-polar. Elements, organic compounds contains many elements. Mostly, primarily, it has carbon. Secondary, it is hydrogen. Apart from carbon and hydrogen must should be there. You may take as simple molecule as methane. You may take as complex molecule as fat, glucose. So carbon and hydrogen are always present. Apart from carbon and hydrogen, there may be nitrogen, there may be sulfur, there may be oxygen, there may be chlorine, bromine, iodine, any other elements. Reactivity, organic compounds are less reactive than the inorganic compounds, right? NaCl is more reactive. Organic compounds like ethanol, right? Fat molecules, they are less reactive. They don't react very quickly. They take time. Isomerism is an important property. Isomerism we'll discuss little later in detail, but it is again one of the feature of the organic chemistry. Preparations, we know that Waller prepared urea in laboratory, so we can also prepare multiple compounds in the laboratory. Difference between organic compounds and inorganic compounds, right? Organic compounds essentially contains carbon and hydrogen, but inorganic compounds not necessarily may contain carbon. Even though there is a carbon, it's not necessary, right, that it becomes a organic compounds. I said that carbon dioxide, carbonic acid, sodium bicarbonate, even though there is a carbon, they are inorganic in nature. It's because carbon is not the essential part of them. Another important feature of the organic compound is covalent bonding. Covalent bonding. Organic compounds all have covalent bondings. Inorganic compounds have ionic bonding. Essentially, carbon and hydrogen are present in the organic compounds. Inorganic compounds may not have carbon and hydrogen. Most of the organic compounds are colorless and most of the inorganic compounds are colorful. Sodium, golden yellow color, right? Potassium have a like purple color. Then organic compounds do not dissolve in water. Inorganic compounds dissolve in water. This is another identity. Like if you want to identify whether it's organic or inorganic, you can put it into water. Vegetables, when you put into water, do they melt? No. So it's organic in nature. But when you put salt into water, does it melt? Yes, it is inorganic in the nature.